Hello and welcome to another episode of BTech. Today we're going to be working on the generator again and doing a few things to help improve how it runs. Now, in the last episode with the generator, we talked about this natural gas conversion kit and how it works. We did modifications to get it on there. And we talked about how the way it's placed in, the choke isn't in the right spot anymore, so you have to do a hand choke to get it started, which on this is right here. That works fine. We also put the lithium ion battery on there. You can see the battery tender hooked up to it, so it's always ready to go. We also ran some additional ground cables. But when it's running under full load, it still seems like it could use a bit more fuel than it's getting. So we're going to address that today in a systematic method. So you can see down there where we have the silicon coupler, which acts as not only a 90-degree bend, but it also does vibration isolation from the exhaust system. Right there, it's just a tractor muffler that I seam welded and put some high temperature paint on, and then we high temperature silicone sealed everything into the double walled chimney, which goes up to my chimney. That seal is perfect. It's undetectable down to 1 part per million for carbon monoxide. So I really like it. Now, what we're going to do though is we're going to cut right at the 90-degree part of that silicon coupler, and then we're going to put a stainless steel section in the middle there. And what that's going to allow us to do is mount a wideband oxygen sensor so that we can look at the air-fuel ratio under different loads, and if we see that we're running lean, we can make some precision adjustments. Those adjustments can be made in several ways. Hopefully we can do it just through the regulator here, but if we need to, we can increase the outlet size here. We can use a system that has fewer bends. Some people made some comments about that, totally right. If we get rid of some of the 90-degree bends, we should hope to get better fuel flow. And then if we have to, we can go down to the actual inlet itself and drill out those inlet ports to see if we can allow more gas flow. So a few things we can do. We may find that it's running just fine, and that's just it's actually at the right air-fuel ratio. So I'm interested to find out. Let me show you how we're going to address this. Oh, almost forgot. We're also going to put a pressure gauge in, at least temporarily, to look at the inlet pressure from the natural gas when the system's off as well, and when it's flowing. Some people asked about if I was able to test my natural gas pressure to confirm it, and no, I was not. So it's going to be part of what we're going to do in this episode. All right, let's get started. All right, here's what we're going to be working with. We have a stainless steel elbow here. It's like a 17 gauge pressure gauge. We have our wideband O2 sensor and gauge, which is a altimeter type. I had this lying around from another project. It never got used. Probably going to use it on the Z. That motor's been being machined and worked on for a few months now, so hopefully we'll get back to the Z project as well. Here's the wideband sensor, and then we have stainless steel bungs to put it right there, or actually we're going to mount it on the side. Go right there. Got a plug for when we're not using it. And then, do we have anything else here? This monstrosity of wires is for the gauge. And then to make the appropriate hole size, we have these carbide teeth here, a hole saw to make the right hole size. And then we'll TIG weld the stainless steel bung on there. A little bit overkill for a little generator, but we like trying to do things right if we can. So first step we're going to do here is make a cut, make a hole, and then we'll weld on our bung, and then we'll go from there. All right, we tested it, and it's a watertight seal, even though it's not the prettiest weld because it's the first time I ever welded stainless steel. But there it is. All right, now so we need to take give this thing a haircut so it'll fit. So we measured inch in on each side. We'll see if that's enough. Nice and you can see it's this way is better. You can see it's in the flow, but not obnoxiously blocking it. All right, so we are double C clamped on, or double pipe clamped on both sides. We'll do a sniffer test to make sure we're not leaking any carbon monoxide. Got our O2 sensor on nice and tight. So we just got to hook up the gauge and the electrical for the O2 sensor. All right, we have the oxygen sensor installed down there. And we have the cabling coming over here, going to the gauge. And then we have the positive and negative going around to the battery, and there's a inline fuse with a connector so I can disconnect the gauge when we're not in use. So we haven't made any changes to the gas lines yet. We're gonna fire it up without any load and see where on the wideband we are measuring. So you can see there, it was running extremely lean. Natural gas is supposed to have an air-fuel ratio, I think around 17 point something. This thing's running over that. So we're gonna start making the first modification, which is going to be to unwind this lining and get rid of the right angles to see if that makes any difference. Earlier you saw I was putting my hand over the air filter and that would richen it out to show that the air fuel, so that the wideband was working. All right, let's make the next mod. So in taking apart the system, I found on this valve there is a massive restriction, so this alone just may improve it, but let me show you what else we did. We also cleaned up the fittings, took out all the angles. So we just have the flex pipe running. Got that pesky valve out of the way. There was a right angle here that was also a needle valve regulator, but this thing's not getting enough gas anyway, so it's not a problem for us. So what we're going to do is start her up again and see if we can do any better with our air-fuel ratio. So we have a 0 to 15 inch of water. It's pretty dang low pressure. You're thinking like 30 inches of water in a 1 psi. Got a valve on there so we can close it off when we're not using the gauge, so we don't get any unintended gas leaks. Let's see if we hit the 11 inches that we're supposed to have in a natural gas system, and if we don't, we know why our regulator is not giving us enough gas. Yep, so we're running low. So you can see we're rated about 7 inches of H2O. So let's bleed a little gas through and see if it stays there. It stays real steady at around 7. So we're going to have to loosen up our regulator to allow more gas through, because it's thinking that we're going to get something like 11 inches of water of pressure, and we're not quite there. All right, well, got the root cause of the problem. To the person that commented in on that, kudos. Really, you were spot on. All right, so we have the regulator off again now that we know that we're still running lean. We're still running lean under load, and we know that our gas pressure is not quite as enough. Let's see what size it is. So 225 fits okay. The old diaphragm. See in there's a spring. Actually some threads. It's going to be really hard to see. I wonder if this is just a cap with an actual adjustment on the other side. So there's some flatheads in here. So you can see in there is something threaded. Well, there we go. It was indeed a cap. It was just really, really hard to get off. Look what we have in here. Oh, dump it out first. An adjustment. Cool. Cool, so we back this screw out a bunch. Push in a bunch. See how it makes, see what that does. Alright, we got the regulator back on, and we tested it for leaks already. 0 leaks. We have an adjustment screw now that we can have access to. And we have our air-fuel ratio. So what we're going to do is we're going to set you up so you can see the air-fuel ratio, and then get the generator fired up. Then once we get it stable under idle, then we'll add a load to it. And with that load, what we'll go ahead and do is see if we can get this thing to stoichiometric, whatever you call it. Get it to that air fuel ratio of 17.2, which natural gas wants to be at under load. So let's see if we can get there. All right, so you see it's running now. It's a little rich at idle, which is totally fine. And then it's just a tad, teeniest tiny little bit rich at under full load. So I'm pretty happy with that. Altogether, things sounds a lot better than when it did. Should start a whole lot easier. Now that's warmed up, let's see if it'll actually start. Much better. All right, well, that's a wrap for this video. Until next time.